Hey everyone, tonight we are setting sail into a world of endless gray, a cold, unforgiving sea where the sun is more myth than guide. Imagine you're on the open ocean, hundreds of miles from the nearest spit of land, and a thick, wet fog wraps around your ship like a shroud. There are no landmarks, no guiding stars, nothing but the groan of timber and the unsettling feeling that you are a tiny speck of dust in a vast, indifferent universe. Let's be honest. Without your phone's GPS and a pocket full of granola bars, you probably wouldn't survive this for more than a day. So before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. It's always fascinating to see where you're all listening from, so feel free to post your location and what time it is in your part of the world. Now dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. The first thing that hits you isn't the cold, though that's a close second. It's the smell. It's a thick, complex cocktail of wet wool, stale sweat, tar, salt, and something vaguely agricultural, perhaps the nervous goat tethered near the mast. Your feet are numb inside your leather boots, which have been soaked through since the last wave crashed over the gunwale 3 hours ago. You pull your cloak tighter, the coarse wool scratching at your neck. It's a garment that has become your blanket, your towel, and your shield against the relentless North Atlantic wind. You're sitting on a hard wooden sea chest, your back pressed against the curved hull of the longship, and every rise and fall of the waves sends a deep, resonant creak through the overlapping planks of oak beneath you. This is the rhythm of your life now. The lurch of the sea, the snap of the square woolen sail above, and the low murmur of voices speaking a language of guttural consonants and lilting vowels. You are one of maybe 30 souls on this Nar, a merchant vessel wider and deeper than the warships of saga fame, but no less audacious in its purpose. You are headed west into a great, terrifying emptiness, chasing rumors of a new land, a place called Iceland, or maybe even further. It is the 9th century, and your people are in the midst of an extraordinary expansion, a diaspora of wood and sail, that will eventually see them establish settlements in Iceland, Greenland, and even, for a brief, flickering moment, the shores of North America. This is a well-established historical fact, the kind of thing you read in a textbook, but the textbook doesn't let you feel the bone-deep dampness, or the gnawing anxiety that comes from staring at a horizon that has looked exactly the same for 2 weeks. An endless, churning expanse of gray water meeting a low, oppressive ceiling of gray cloud. You glance around at your shipmates. They are a rough-hewn bunch, their faces chapped red by the wind, their beards spangled with sea spray. A few are sleeping, huddled together for warmth like a pile of puppies. Others are mending a fishing net, their fingers working nimbly despite the cold. Over by the mast, a large ginger cat is meticulously washing its face, utterly unconcerned with the oceanic turmoil. It's a reminder of a quirky, practical truth of these voyages. Cats were essential crew members, valued far more for their mousing abilities than their companionship. Keeping the ship's meager grain stores and dried fish safe from rodents was a matter of life and death out here. A ship without a cat was a ship inviting famine, and seeing that small creature so calm and domestic in this wildly alien environment is somehow both comforting and absurd. You wonder if it ever gets seasick. Probably not. It has more dignity than you do right now, that's for sure. The real problem, the one that sits like a cold stone in your gut, is the sky. There is no sun. Not a hint of it. No bright spot behind the clouds. No subtle shift in the light to tell you where east or west might be. It has been like this for 4 days. The navigator, a stern, quiet man named Bjorn, stands near the steering oar at the stern, his gaze fixed on nothing you can discern. How does he do it? How does he point the nose of this wooden beast into a featureless void and claim to know the way? You have no magnetic compass. That invention is centuries away from reaching your corner of the world. You can't see the stars. At night, the cloud cover is just as thick, a smothering black blanket. During the brief, hazy summers at this latitude, the sun often refuses to set at all, just hovering near the horizon in a perpetual, disorienting twilight. It renders celestial navigation, the kind that sailors in the south might use, maddeningly difficult. Historians still argue whether their incredible voyages were the result of a secret technology, sheer dumb luck, or an environmental awareness so profound it might as well have been a superpower. You watch Bjorn, this silent man upon whom all your lives depend. He occasionally dips a hand into a small leather pouch at his belt, his fingers closing around something you can't see. Is it a good luck charm? A religious token? Or is it something more? The ship groans again, a long, low complaint as it slides down the back of another massive swell. The gray mists swirl, and for a moment you feel a profound and terrifying sense of being utterly and completely lost. You are adrift in a world without direction, and your only hope lies in the possibility that your navigator can see something in this endless gray that is entirely invisible to you. This oppressive grayness isn't just a mood, it's a technical problem of the highest order. Your entire sense of direction, hardwired into your human brain since your ancestors first walked upright, relies on a few basic cosmic certainties. The sun rises in one direction, sets in another, and casts shadows that tell a story of the passing day. But here, in this northern realm, the sun is a liar. Even on a clear day, it's a shifty, unreliable guide. You've seen it. Back near the coast of Norway during the height of summer, the sun simply refused to set. It just kissed the horizon in the north, looking for all the world like a sunset, before deciding, nah, I'm not done yet, and starting to climb back into the sky. Trying to navigate by that is like trying to tell time with a clock that has no numbers and whose hands spin at random speeds. The arc it travels is all wrong. Near the equator, the sun leaps into the sky, traces a high, dramatic path, and then plunges back down. Its peak, high noon, is an obvious, unmissable event. Here, it's a low, lazy curve. The sun seems to drag itself reluctantly across the sky, never gaining much altitude. Finding its highest point is an exercise in frustration, like trying to identify the tallest blade of grass in a freshly mown lawn. The difference between 11 a.m., noon, and 1 p.m. is so subtle that your best guess for south could easily be off by 20 or 30 degrees. And an error that's small, compounded over weeks at sea, is the difference between making landfall in Greenland and ending up as a new, undiscovered food source for polar bears in the icy wasteland far to the north. Then there's the twilight. In these latitudes, the sky doesn't simply get dark. It enters a prolonged, luminous period of dusk that can last for hours, a state of neither day nor night where the light is flat and shadowless. This pale, directionless glow bleeds into everything, erasing the textures of the waves and washing out the color of the sky until it all merges into one continuous pearlescent sphere, with you at its center. It's beautiful, in a terrifying, disorienting sort of way. You are living inside a giant pearl, and there are no exits. This constant, hazy light messes with your internal clock, making sleep a disjointed, unsatisfying affair. Your world is stripped of its temporal and spatial cues, leaving you feeling untethered and adrift in more than just the literal sense. It's a strange irony that your voyage is taking place during what historians call the medieval warm period. This was a time from roughly 950 to 1250 AD, when global temperatures were a bit toastier than in the centuries that followed. This likely meant less sea ice blocking the passages of the North Atlantic, arguably making these ambitious westward expansions possible in the first place. But warmer air meeting a vast cold ocean creates the perfect recipe for one thing: fog. So while the water might be slightly less prone to freezing you solid in 30 seconds, the air itself becomes a thick, wet wall of white. It's an advection fog, formed when moist, warm air passes over a cooler surface. It can roll in without warning, reducing visibility from miles to mere feet in a matter of minutes. Sounds become deadened, the cries of gulls and the crash of distant waves swallowed by the damp air. The world shrinks to the confines of your ship, a tiny bubble of existence in a sea of nothing. Your people have a specific word for the profound, soul-crushing disorientation this causes: hafilla. It's more than just being lost. It's a state of total sea bewilderment, a navigational paralysis where you have lost all your bearings. You have no idea which way you came from, which way you're going, or even which way is up on a particularly bad day. Hafilla was a deeply feared condition, the sailor's ultimate nightmare, spoken of in hushed tones around the fire back home. It meant you were at the mercy of the currents and the wind, your fate now entirely in the hands of the gods. And as you sit here, shivering in the damp, You understand it completely. You are in the clutches of Havila. It's an almost physical sensation, a pressure in your ears and a lightness in your head. Scholars continue to debate the frequency and duration of these blinding fogs during the Viking Age, with some arguing that clear days were common enough to make simple sun sighting viable, while others contend that the voyages to Greenland and beyond would have been statistically impossible without a reliable backup. Relying on the sun in the North Atlantic feels like trusting a notoriously flaky friend to pick you up from the airport. They might show up, but they also might get distracted by a food truck and forget you exist for 3 days. You watch Bjorn, the navigator, his face an unreadable mask. He seems immune to the Havila that is creeping into your own heart. He just stands there, patient, occasionally glancing up at the impenetrable wall of gray above. Is his confidence an act? Is he just better at hiding his terror than the rest of you? Or does that little leather pouch at his belt hold the answer? Does it contain some way to cut through the lies of the northern sun and find the truth hidden behind the fog? Just as the cold dampness seems to have burrowed its way into your very bones, a voice cuts through the fog beside you. It's Einar, an old sailor whose face is a roadmap of wrinkles carved by decades of sun and sea. He sees you staring at Bjorn, your expression a mixture of awe and desperation. He gives a low chuckle, a sound like stones grinding together. Watching the sky reader won't make the sun appear, boy, he murmurs, his breath pluming in the cold air. But he has his ways, the old ways. You ask him what he means, what possible way there could be in this endless soup. He settles himself on the sea chest next to you, the wood groaning in protest, and begins to talk, his voice a low counterpoint to the rhythmic creak of the ship. He speaks of the sagas. You've heard them all your life, of course. They are the great stories of your people, recited by skilled storytellers during the long, dark winters. These aren't simple bedtime stories. The Icelandic sagas are sprawling, intricate epics, a blend of family history, brutal feud, legal dispute, and high adventure. In the modern world, we'd probably call them a multimedia franchise, part historical drama, part courtroom procedural, and part over-the-top action movie. They tell of figures like Egil Skallagrimsson, a warrior poet who was as quick with a verse as he was with an axe, and Gudrid Thorbjarnardóttir, the most traveled woman of the age who gave birth to the first European child in North America. These stories are your history, your entertainment, and your moral compass all rolled into one. Einar lowers his voice, as if sharing a secret. He tells you a fragment of a story you haven't heard before, about a great king on a ship, caught in a snowstorm, much like your current predicament. The king, he says, wanted to know the sun's position, but the sky was a blanket of white. So he called for his sólarsteinn. You repeat the word, sólarsteinn. It feels heavy on your tongue. Sunstone. Einar explains that with this stone, the king was able to pinpoint the location of the sun even though it was completely invisible, and win a bet against a rival. The story is brief, almost a throwaway line in a much larger narrative, but the idea sticks in your mind. A stone that can find the sun. It sounds like magic, a poet's fantasy. The strange thing is, these sagas that Einar is quoting are the primary, and for a long time the only written evidence we have for such a device. This is a crucial historical fact. The sagas were passed down orally for generations, but they weren't actually written down until the 12th and 13th centuries, mostly by Christian monks and scholars in Iceland. That's a good 200 years after the height of the Viking Age they describe. This time lag creates a huge problem for historians. It's like trying to understand 1980s pop culture by watching a movie made about it today. The general themes might be right, but the details could be wildly exaggerated or misunderstood. Did the original storytellers talk about a real tool, or did a later scribe add a touch of the miraculous to spice things up? It's even more remarkable when you consider what these texts are physically made of. They were painstakingly copied by hand onto vellum, which is specially prepared animal skin. A single large saga might require the hides of an entire herd of calves. This wasn't cheap or easy. The information was considered so valuable that it was worth a fortune in livestock just to preserve it. The idea that a scribe would use up a piece of this incredibly precious material to jot down a piece of pure fantasy seems unlikely. Yet the sólarsteinn is mentioned so casually, with so little explanation, as if everyone at the time would have known exactly what it was. It's a frustratingly brief and tantalizing clue. You voice your skepticism to Einar. A magic stone? He just shrugs. A slow movement of his broad shoulders. Magic is just a word for a tool you don't understand, he says. A surprisingly profound statement from a man who smells faintly of pickled fish. As he speaks, a few other crew members who were pretending not to listen edge closer. The fog hasn't lifted. The cold is still biting. But for a few minutes, the shared focus on Einar's voice creates a small bubble of warmth and community in the oppressive emptiness. Storytelling isn't just a way to pass the time. It's a vital technology in itself, a way of weaving a rope of shared knowledge and morale that holds the crew together when the sea is trying to pull everything apart. The story of the Sunstone isn't just a legend. It's a reminder that your ancestors faced this same hafila and found a way through. It's a kernel of hope. Still, the debate echoes in your mind, a reflection of the one that rages among scholars today. Historians still argue whether the mentions of the sólarsteinn in the sagas are literal descriptions of a real navigational tool, allegorical references to a leader's divine insight, or simply a fantastical element added by later Christian scribes to make the old pagan heroes seem almost magical. Einar's story trails off as a shift in the wind requires a slight adjustment of the sail. He gets up to help, leaving you with the half-finished tale and the lingering resonant word, sólarsteinn. You look over at Bjorn again. He has his hand on the pouch at his belt. Suddenly, it's not just a leather bag anymore. It's a vessel of possibility, a tangible link to the legends Einar just spoke of. The mystery of how you'll survive this journey has just been given a name. The sail is secure, taut against the wind that seems to blow from all directions at once. Einar makes his way back to you, his movements sure-footed on the slick, swaying deck. He settles back onto the chest with a grunt. You don't waste a moment. The king, you prompt him. The sólarsteinn. What happened? Einar smiles, seeing he has a captive audience. The story of Holy Olaf, he begins, and his voice takes on the formal, rhythmic cadence of a practiced storyteller. It was not on the sea this happened, but in his great hall, with the winter snows falling thick outside. He paints the scene for you. It is a bleak, overcast day. King Olaf of Norway, the great unifier and Christianizer of your people, is holding court. The fires are roaring, the ale is flowing, but the world outside is a featureless expanse of white. The king is engaged in a friendly contest of wits with his chieftains, a classic Viking pastime that is a bit more intellectually demanding than their usual hobbies of raiding and feuding. He turns to a man known for his sharp eyes and keen senses and asks him a simple question. Tell me, where is the sun now? The man stares out the window at the swirling snow and the uniformly gray sky, makes his best guess, and points to a patch of cloud. This is where the story pivots from a simple anecdote to a tantalizing technological mystery. The king, with a knowing look, calls to an attendant, "Bring me the Sunstone." Einar pauses for dramatic effect, letting the words hang in the damp air. An attendant returns and presents the king with the stone. The saga, Einar explains, doesn't bother to describe it. It could be a pebble or a boulder for all the text tells us. Olaf takes the sólarsteinn, holds it up and gazes at the sky. And through the thick clouds, through the falling snow, the saga says he could see where the sun radiated from. He then declares the true position of the sun, proving the other man wrong and confirming his own superior wisdom. His pronouncement, the saga concludes with simple finality, did not fail. The king in this story, Olaf II of Norway, was a very real person. He was a complex and often brutal ruler who fought to unite Norway under his crown, and crucially, to replace the worship of the old gods like Odin and Thor with Christianity. His efforts made him a lot of enemies, and he was eventually killed in the Battle of Stiklestad in 1030. Almost immediately, tales of miracles associated with him began to spread, and he was canonized, becoming Saint Olaf. This historical context is vital. Is the saga describing a real event with a real tool, or is it a piece of hagiography, a saint's biography, designed to make Olaf seem miraculous. Giving a saint the power to find the sun in a storm certainly fits the narrative of a holy man with a special connection to God's heaven. The account is both fascinating and infuriatingly vague. What kind of stone? How did he hold it? Did he look through it like a lens, or at it like a screen? The text offers no clues. It's the equivalent of finding an ancient instruction manual that just says, "To operate the celestial particle accelerator, first acquire the device. Then simply operate it." Thanks for nothing, ancient scribe. This lack of detail is the very heart of the Sunstone mystery and has allowed for centuries of speculation. It's specific enough to make you believe it's real, but vague enough to make it impossible to prove from the text alone. What's even more curious is the context. The saga presents this not as a life or death navigational challenge at sea, but as a kind of party trick. It's a king showing off in his hall, using this remarkable object to win an argument and look clever in front of his court. It's less about survival and more about status. Another, even more cryptic account found in a text called Raudolf's Tatter describes a different stone that was used to tell the hours of the day when the sun was hidden. This stone was placed in a bowl of fresh water, and somehow its properties helped reveal the sun's location. Two different stories, two slightly different methods, but the same core idea. A stone that makes the invisible visible. Of course, this is where the real arguments begin. Archaeologists and literary scholars still debate whether this account is a garbled description of a genuine scientific instrument or a hagiographic flourish designed to elevate Saint Olaf by giving him a seemingly supernatural power over the elements. Is it physics or faith? A tool or a talisman? The line between the two was much blurrier in Olaf's time than it is today. Einar finishes his tale and falls silent, leaving you to ponder its meaning. The story of a sainted king in his warm hall feels a world away from your current, freezing predicament on the open ocean. And yet, the central promise is the same. The idea of finding a single fixed point in this swirling, featureless chaos is almost too hopeful to believe. You look at Bjorn, then back at the thick gray sky. For the first time you feel like you might know the question to ask. Not where are we, but what's in the pouch. You try to reconcile the story Einar told you, a tale of saints and kings, with the gritty, unforgiving reality of the sea around you. A magic stone feels like a child's answer to a grown-up's problem. Your mind, even without the formal frameworks of a future science, rebels against the idea. There must be a trick to it, a physical property, not a supernatural one. The world operates on rules. Wood floats, iron sinks, fire is hot, and the ocean is trying its level best to kill you. Surely a stone that finds the sun must also obey some rule of nature, one that is simply not obvious to the uninitiated. You stare at the dull, uniform sky and a question forms in your mind, a departure from the world of sagas. How could a rock possibly work like that? You are not the first person to ask this question. For centuries, the sólarsteinn was dismissed as pure folklore. But then, in 1967, a Danish archaeologist named Thorkild Ramskau looked at the legend with fresh eyes. He proposed a theory that was both scientifically sound and incredibly elegant. He suggested that the sunstone wasn't a magical artifact at all, but a specific type of naturally occurring crystal that could detect polarized light. And with that one idea, he yanked the sunstone out of the realm of fantasy and into the world of physics. To understand what he meant, you have to think about light itself. Light from the sun isn't a neat, tidy beam. It's a chaotic jumble. Imagine sunlight as a wave traveling through space, but it's not just vibrating up and down. It's vibrating up, down, side to side, diagonally, and in every other direction at once, all perpendicular to its direction of travel. If it were a rope you were shaking, you'd be flailing your arm around like you were trying to fight off a swarm of invisible bees. It's a mess of raw energy. This is unpolarized light. Now, imagine you send that chaotically shaking rope toward a picket fence. The fence has narrow, vertical slats. The only part of the rope's wild vibration that can pass through is the up and down motion. All the side-to-side and diagonal wiggles get blocked. What comes out the other side is a neat, orderly wave moving only in the vertical plane. That is polarized light. This is the exact principle behind your fancy polarized sunglasses. They contain a microscopic chemical filter that acts like a tiny picket fence, blocking the horizontally polarized light that reflects off surfaces as glare, while letting the useful vertically polarized light through. The Vikings obviously did not have access to a sunglass hut, but they did have access to something that does the same job naturally: crystals. The scientific discovery of this property, known as double refraction in calcite crystals, was first formally documented by another Dane, Rasmus Bartholin, way back in 1669. This is a key historical fact. The Vikings would have had no concept of electromagnetic wave theory, but they didn't need it. They just needed to pick up a rock, look through it, and notice that it did something weird and useful with light. So, where does this magical polarized light come from in the sky? The sun itself produces unpolarized light. The magic happens when that light enters our atmosphere. As the sunlight travels through the air, it smacks into tiny molecules of nitrogen and oxygen. This collision scatters the light in all directions. And crucially, this scattering process polarizes it. The scattered light that comes to your eye from a patch of blue sky has been filtered by the air itself. This creates a vast, invisible pattern across the entire dome of the sky. The strongest polarization occurs in a huge ring, 90 degrees away from the sun's actual position. So, even if the sun itself is hidden behind a thick bank of clouds, that invisible ring of polarized light is still there, imprinted on the base of the clouds like a secret compass. The Sunstone isn't a telescope for seeing through clouds. It's a decoder for reading the secret message the sky is always broadcasting. It's a trick that nature figured out a long time ago. Many insects, like bees and ants, have compound eyes that can perceive polarized light directly. They use this celestial map to navigate back to their hives and nests with incredible accuracy, even on overcast days. Your Viking navigator wasn't doing anything supernatural. He was just trying to replicate an ability that every humble honeybee is born with. It's like they invented bee vision goggles out of a rock. Of course, it's not a perfect system. Physicists and historians still debate the degree to which very thick cloud cover or fog would disrupt this atmospheric polarization, potentially rendering the sunstone useless in the very conditions where it was needed most. A light, uniform overcast might be fine, but a dense, multi-layered storm front could scramble the signal completely. The theory is elegant, but the North Atlantic is a messy place. You look at Bjorn's pouch again. The new theory clicks into place in your mind. It's not a talisman containing the favor of a god. It's a tool, a piece of the earth, forged by immense pressure and time, that happens to have a crystal lattice so perfectly ordered that it can sort the chaos of sunlight. It's not magic, it's something much, much cooler. It's order from chaos. Your perspective has fundamentally shifted. The sky is no longer a uniform, oppressive blanket of gray. You now understand it as a canvas, albeit one painted in invisible ink. Your mind races to picture it, this secret pattern that Bjorn can apparently read. You try to visualize the physics you've just pieced together, imagining the journey of a single photon of light from the sun, 100 million miles away, as it ends its trip in the Earth's atmosphere. That final, crucial collision with an air molecule is the key to everything. This process has a name: Rayleigh scattering. It's the very same phenomenon that, on a clear day, makes the sky appear blue. The tiny molecules in the air are far more effective at scattering the short, punchy wavelengths of blue light than they are at scattering the long, lazy wavelengths of red light. So the blue light gets bounced around and scattered all over the sky, eventually reaching your eyes from every direction, making the whole dome above you look blue. The red light, being less easily sidetracked, tends to punch straight through, which is why the sun looks reddish at sunrise and sunset when its light has to travel through more atmosphere to get to you. It's the intergalactic equivalent of getting all the easy questions on a test wrong, but acing the final boss. But this scattering doesn't just change the light's color, it organizes it. It stamps a predictable pattern of polarization onto the sky. The easiest way to picture this pattern is as a gigantic invisible bow tie stretching from horizon to horizon, with the sun located right in the middle, at the knot. The two big lobes of the bow tie are on opposite sides of the sun and the direction of the polarization, The orientation of our picket fence slats is always perpendicular to a line drawn from that point in the sky back to the sun. So if you're looking at a patch of sky directly above the sun, the polarization will be horizontal. If you look at a patch of sky to the left of the sun, the polarization will be vertical. It's a perfect celestial grid, an architectural blueprint overlaid onto the chaos of the clouds. The most useful part of this pattern is a massive ring of maximum polarization that is always exactly 90 degrees away from the sun. Think of it as a giant halo painted on the sky. If the sun is just rising in the east, this halo would run from the north celestial pole, directly overhead, down to the south celestial pole. If you can find any part of this ring, you know the sun must be a quarter turn of the sky away from it. The sunstone is the tool that lets you see the halo. When you look at the sky through a polarizing crystal and rotate it, the crystal will appear to get darker and lighter. When it's at its darkest, its primary axis is aligned perfectly with the direction of the polarization in that patch of sky. You found the orientation of the invisible bow tie. Interestingly, you might not even need the stone. Some people can perceive a faint, yellowish bow tie or hourglass shape right in the center of their vision when they look at a field of polarized light. This is a real biological phenomenon called Heidinger's brush, first described in 1844. It is caused by the selective absorption of light by pigment molecules in your retina. Most people never notice it, but it's there, a latent human superpower. It's entirely possible that some Viking navigators were naturally more sensitive to this effect, and the Sunstone simply served to amplify and confirm what their own eyes were subtly telling them. Armed with this knowledge, navigation becomes a kind of celestial treasure hunt. Bjorn doesn't need to see the sun, he just needs to find two different points on the invisible bow tie. He can hold the crystal up to a patch of sky to his left, rotate it, and find the angle of maximum darkness. Then he can do the same for a patch of sky to his right. Each measurement gives him a line of orientation, and where those two lines converge, according to the rules of the celestial bow tie, there is the sun. X marks the spot. It transforms the terrifying, disorienting experience of Havila into a simple geometry problem. The science is so elegant that it even extends beyond the sun. Moonlight is just reflected sunlight, and it's also polarized. The patterns are weaker and more complex, but a fringe theory suggests that on a bright, moonlit but overcast night, a very clear crystal could theoretically be used to find the moon's position, giving a navigator a desperately needed bearing in the darkness. Of course, the theoretical elegance of this system is one thing, its practical application is another. Atmospheric scientists and experimental archaeologists still argue whether the theoretical clarity of this polarized pattern holds up in the messy real-world conditions of the North Atlantic, where multiple layers of cloud can scatter and rescatter, the light effectively scrambling the signal into useless noise. But for you here on the ship, the theory is a lifeline. The world suddenly feels less random. You look up at the gray clouds, and instead of an empty void, you imagine this immense, beautiful geometric structure arching over the entire ocean. The world has a hidden order. The ship isn't truly lost in a featureless soup. It is, and always has been, inside a massive natural compass. You just didn't know how to read it. You look at Bjorn, who now seems less like a grizzled sailor and more like a high priest of the hidden light, an interpreter of the sky's secret language. And the ship, your tiny, fragile home, suddenly feels a little less alone in the vast, gray sea. Your mind is now humming with this new physical model of the world, one filled with invisible patterns and secret celestial rules. But a theory, no matter how elegant, is nothing without the right instrument. Your gaze keeps returning to that small leather pouch on Bjorn's belt. The question has become more specific. It's no longer just what's in the pouch, but what kind of rock is in the pouch? What mineral available to a 9th century Norseman possesses the strange optical properties needed to decode the sky? This is where the scientific detective story begins, shifting from the lofty realm of atmospheric physics to the gritty, tangible world of geology. Working backward from the function described in the sagas, researchers have identified a short list of 3 main crystalline suspects. The first contender is a mineral called cordierite. In its raw form, it might not look like much, just a glassy, grayish stone. But when cut and polished, it often reveals a beautiful violet or blue hue. Its connection to the Vikings is so strong in popular imagination that it is sometimes nicknamed the Vikings' compass. Its special trick isn't that it gets darker or lighter, but that it dramatically changes color. This property is called pleochroism, which is a fancy way of saying many colors. If you hold a piece of cordierite up and look at the sky, it might appear a deep, rich violet. But if you rotate it 90 degrees, that violet will instantly drain away, replaced by a pale, translucent yellow. This stark color shift is directly linked to the orientation of polarized light. To use it, you wouldn't be looking for a point of maximum darkness, but for the angle that gives you the deepest, most saturated blue. That tells you the direction of the sky's hidden polarization. Even better, significant deposits of gem-quality cordierite are found right in the heart of the Viking world, in Norway and Sweden. The raw material was, quite literally, right under their feet. Our second suspect is tourmaline. You've probably seen this in jewelry. It comes in a rainbow of colors, but the type useful for navigation would likely be a dark green or black variety known as schorl. Like cordierite, it's found in Scandinavia. Tourmaline is a natural polarizer. It doesn't just change color, it actively blocks light vibrating in a certain plane. It is the picket fence, embodied in a crystal. You would hold it up, look at the sky through it, and rotate it until the image became as dark as possible. Simple, effective, and straightforward. So why isn't it the number one suspect? The main drawback is its darkness. Tourmaline crystals can be very, very dark to begin with. Trying to detect a subtle dimming of an already dim, gray, overcast sky through a dark filter is a recipe for eye strain and uncertainty. It would work brilliantly on a bright, hazy day, but in the thick fog and gloom of the deep North Atlantic, it might be like trying to read a newspaper in a coal mine. It's a plausible tool, but perhaps not the most practical one for the job. Now, we have to consider the Vikings' reach. Their world wasn't limited to the rocks they could find in their own backyard. This was the age of the great Viking trade routes, a historical fact that is often overshadowed by their reputation as raiders. They were merchants and explorers who established commercial networks stretching from the rivers of Russia down to Constantinople and across the Middle East. They traded furs, amber, and walrus ivory for silver dirhams, silk, and spices. This network means that if a better, more suitable crystal existed somewhere else, they likely had the means to acquire it. This brings us to the prime suspect, the geological A-lister, the candidate that makes most researchers' hearts beat a little faster. Iceland spar. Iceland spar is a remarkably pure, transparent form of the mineral calcite. It often cleaves into a perfect rhombohedron, a slanted cube that looks like a chunk of perfectly clear ice or glass. Its name gives away its most famous location. While calcite is common worldwide, exceptionally large and optically pure deposits were discovered in Iceland, most famously at the Helgustadir mine, which was in operation from the 17th to the 20th century, but whose deposits would have been accessible much earlier. The Vikings began colonizing Iceland around 874 AD. The geographical and chronological overlap is tantalizing. They arrive on a new island, and there they find the most powerful polarizing crystal known. It seems too perfect to be a coincidence. This crystal has a truly unique and mind-bending property known as birefringence or double refraction, which sets it apart from all others. The idea of using a polarizing filter as a navigational aid is so sound that it was actually reinvented in the 20th century. During World War II, American bombers flying long-range missions over the polar regions found their magnetic compasses to be unreliable, so they were equipped with a device called the Fund Sky Compass, which used a simple polarizing filter to locate the sun's position relative to the aircraft, allowing for accurate navigation. It was a modern, engineered sunstone for an entirely new kind of Viking. With all these options, the mystery remains. Geologists and historians still debate which of these crystals, if any, best fits the cryptic descriptions from the sagas, as each has its own unique strengths and weaknesses as a navigational tool. Was it the color-shifting cordierite, the darkening tourmaline, or the light-splitting Iceland spar? As you sit on the deck, you run through the lineup of geological suspects in your mind. You picture Bjorn's hand reaching into his pouch and pulling out a crystal. Which one do you see? Your imagination settles on the Iceland spar, the clear, crystalline block that seems to hold a strange, geometric magic within it. You're fixated on this one candidate, Iceland spar. It's the crystal from the land the Vikings themselves named, a place of fire and ice. There's a poetic rightness to it. But what is this double refraction that makes it so special? You imagine Bjorn finally acquiescing to your silent curiosity, reaching into his pouch and producing a small, translucent, diamond-shaped crystal. He doesn't hold it up to the sky. Not yet. First, he gestures for you to look at a single knot in the wooden deck plank at your feet. Then he places the clear stone over the knot. And suddenly, where there was one knot, now there are two. They are both perfectly clear, perfectly solid, yet one is a ghostly twin of the other. You can't explain it. You blink, shake your head, and look again. Two knots. It's an immediate, undeniable, and deeply weird optical trick. This phenomenon, birefringence, is the secret weapon of Iceland spar. The crystal's internal structure is so rigidly organized that when a beam of unpolarized light enters it, it gets split in two. Think of it like a bouncer at a very exclusive nightclub for photons. The bouncer sorts the incoming crowd of chaotically vibrating light waves into two neat, orderly lines. The first line, called the ordinary ray, is allowed to pass straight through. The second line, the extraordinary ray, is shunted off to the side, forced to take a slightly different path. The critical part is this. These two new rays, these two lines of light, are now polarized, and their planes of polarization are at perfect right angles to each other. So the crystal isn't just creating a double image. It's physically separating the two perpendicular components of light and showing you both at the same time. This is where the magic trick becomes a high-precision navigational instrument. Because the two images you see are made of differently polarized light, they react differently to the sky's hidden pattern. Imagine Bjorn now holds the crystal up and looks through it at a patch of sky directly overhead. He sees two images of the gray clouds. If the light from those clouds is polarized, and you know it is, then one of the images will appear slightly darker than the other. This is because the crystal's two internal axes are interacting with the sky's single axis of polarization. One image is aligned more closely with the sky's picket fence, and the other is not. Now for the brilliant part. Bjorn begins to slowly rotate the crystal. As he turns it, the brightness of the two images inside the stone will shift. The darker one will get brighter, and the brighter one will get darker. He keeps turning slowly, carefully, until he finds the one single unique orientation where the two images are of exactly equal brightness. The point where the ghostly twin is indistinguishable from the original. This is the moment of navigational truth. When that balance is achieved, a line drawn through the main axis of the crystal is pointing directly at the sun. It's an astonishingly elegant and unambiguous signal. You're not trying to guess the darkest point or the most blue color, which are subjective judgments. You are using your eye's exquisite ability to detect minute differences in contrast to find a point of perfect equilibrium. It's like balancing a scale. You know, with absolute certainty, when it's level. This property was so strange that when the Danish scientist Rasmus Bartholin first documented it in 1669, it threw the scientific world into a state of profound confusion. He published his findings on the wonderful crystal from Iceland, noting that it produced a double image, a phenomenon that seemed to defy the known laws of optics. Isaac Newton couldn't fully explain it. It took the development of the wave theory of light by Christian Huygens to even begin to make sense of it. The thought that your rough sea-beaten companions might be casually using a principle of physics that would stump the greatest minds of the European scientific revolution 700 years later is a deeply humbling one. In a strange twist of linguistic fate long after the Viking Age, the term sunstone was sometimes used in scientific circles to refer to Iceland spar, purely because of its sun-like optical qualities and its use in creating scientific instruments for studying light. Its legendary name and its scientific one found each other again, centuries later, almost by accident. Of course, the real-world application is never as clean as the theory. Experimental physicists still debate the achievable accuracy of this method under various sky conditions, with some studies suggesting it can pinpoint the sun's location to within a single degree, an incredible feat. while others argue that atmospheric interference would create a much larger margin of error. But as you imagine the process, the accuracy almost doesn't matter as much as the certainty it provides. To be lost in the Hafila, in a world of infinite gray, and to have a tool that can provide a single fixed point, it's the difference between chaos and order. You see Bjorn in your mind's eye, holding the clear stone, turning it with a slow, practiced motion, his entire focus on the two faint images within. He is not praying to the gods or looking for omens in the waves. He is performing an experiment. He is a physicist of the open ocean. And the pouch at his belt now seems to hold not just a crystal, but the very concept of certainty itself. The theory is one thing, a neat and tidy puzzle solved in the calm laboratory of your mind. But now it's time for the practical exam. You put yourself in Bjorn's shoes. The wind is howling, the sea is a chaos of moving hills, and 30 pairs of anxious eyes are fixed on you. The oppressive weight of Hafila is a physical presence. You are the only one who can break its spell. How do you actually do it? This isn't an academic exercise, it's a matter of life and death. First, you need a moment of relative stability. You plant your feet wide on the wet deck, bending your knees to absorb the ship's relentless motion. You might brace yourself against the solid oak of the mast or the raised stern castle. Your vessel, a nar, is built for this. Its clinker construction, with overlapping planks riveted together, creates a hull that is both incredibly strong and surprisingly flexible. It's designed to writhe and twist with the waves, to ride over the swells like a living creature rather than smashing through them. This flexibility, this harmony with the ocean, gives you the precious seconds of stability you need. Your movements are slow, deliberate, a small ritual of calm in the heart of the storm. You reach into your leather pouch. Let's say you pull out the prime suspect, a clear rhomboid crystal of Iceland spar. You also take out a small flat piece of wood with a single dark dot of charcoal drawn in its center. You don't just hold the crystal up to the sky. That would be useless. You place the crystal directly over the dot. Immediately, the single dot becomes two. Now you have your instrument. Holding the piece of wood carefully, you raise it until you are looking through the crystal at the sky directly overhead, at the zenith. This is the best place to take a reading, as the polarization effect is often clearest there. Now, the delicate work begins. Keeping your eyes fixed on the two dots, you begin to rotate the crystal. The sea lurches, and you have to adjust your whole body to keep the instrument steady. A wave of nausea might wash over you. Even the most seasoned sailors aren't immune. But you push it down. Your entire world shrinks to those two charcoal dots, shimmering with the faint gray light of the overcast sky. At first, one dot is clearly brighter than its ghost twin. As you turn the crystal, their intensities shift like two singers trying to find the same note. You turn it a fraction more, and then you see it. The two dots snap into perfect equilibrium. They are identical. There is no longer a primary and a ghost. There are just two equal points of light. In that instant of perfect balance, you freeze. The main axis of the crystal in your hand is now a physical arrow, an invisible line stretching from your ship through the heart of the stone across the miles of cloud and ending at the precise location of the hidden sun. What if your pouch contained cordierite instead? The process would be more subjective. You would hold the violet-blue stone up to the sky and rotate it. You're not looking for balance, but for brilliance. You turn it, searching for that one angle where the color is at its most vivid and deep, a flash of royal blue against the gray. When you find it, you found the orientation of the sky's polarization. You know from experience, from long days of practice in clear weather, how that orientation relates to the sun's position. It's less precise, more of an art, but for a skilled navigator, it could be enough to find a bearing. Of course, the debate rages on. Researchers still argue about whether a single-point reading from the zenith would be sufficient, or if a navigator would have needed to take multiple readings from different parts of the sky to triangulate the sun's position with any real accuracy. And some have proposed an ingenious secondary step. Once you have the sun's general direction from the crystal, you could hold up a small vertical stick called a gnomon. Even in this diffuse light, the sun would cast an incredibly faint, almost imperceptible shadow. By marking the edge of this ghost shadow, you could confirm and refine the reading from the Sunstone, adding a layer of much-needed precision. But for now, your single reading is enough. You have a direction. The sun is over there, off the port bow. You know from the gnawing in your stomach and the feel of the air that it must be mid-morning. If the sun is there, then west must be that way. You lower the crystal, carefully placing it back in its pouch. You turn to the helmsman, who has been watching you with the focus of a hawk. You don't need to shout. You just point. There, you say. Hold that course. A ripple of relief passes through the crew. The tension that has been coiling in the air for days finally breaks. Men start talking again. A joke is shared. The ginger cat stretches and yawns. The Hafvila is broken. You are no longer lost. You have a direction. And in the middle of the vast indifferent ocean, a direction is the same thing as hope. A palpable sense of order has been restored to your small floating world. You have a direction, a course to follow. The quiet confidence of the navigator, Bjorn, seems to have spread to the entire crew. The Sunstone theory makes perfect logical sense. The physics is elegant, the proposed method is practical, and the sagas, however vague, provide the textual seed. It all fits together into a satisfyingly complete picture of Viking genius. You lean back against the sea chest, a feeling of intellectual security settling over you. And then, a cold, nagging question begins to creep in from the edges of your mind. If this tool was so revolutionary, so essential for the westward expansion that defined an era, where are they? This is the great, inconvenient, and deafening silence at the heart of the Sunstone theory. For all the excitement it generates, for all the papers written and experiments conducted, archaeologists are faced with one stark fact. Not a single confirmed sólarsteinn has ever been excavated from a Viking Age archaeological site. Not one. It is the ghost at the feast, the elephant in the longship. If these stones were the key to unlocking the Atlantic, then they are a key that has completely vanished from the historical record. It's not for lack of looking. The Viking archaeological record is astonishingly rich and detailed. Over the last century and a half, thousands of graves have been meticulously excavated, from the coast of Norway to the Viking settlements in Dublin. We have unearthed entire ships like the magnificent Gokstad and Oseberg vessels, buried as funerary goods for their high-status owners. We have mapped out their towns and farmsteads. We have their swords and axes, their intricate jewelry of silver and gold, their carved wooden idols, their bone combs, and even the little metal pieces for their favorite board game, Hnefatafel. We have found coins minted in Baghdad and silk from Byzantium, proof of their vast trading networks. We have everything down to the tweezers they used for personal grooming, because apparently even a fearsome raider worried about rogue eyebrow hairs. We have a detailed, high-resolution snapshot of their material world, and in that entire, sprawling catalog of artifacts there is a sunstone-shaped hole. This is what's known as an argument from silence. Logically, the absence of evidence is not evidence of absence. Just because you haven't found something doesn't prove it never existed. But the longer and more thorough the search, the more significant that silence becomes. If you can't find your car keys after a quick glance at the kitchen counter, it doesn't mean much. If you can't find them after you've disassembled the entire house, hired a team of forensic accountants to track their movements, and interviewed the cat under a bright light, you can be reasonably sure they aren't there. The archaeological search for the Sunstone is getting closer to the second scenario. So, how do proponents of the theory explain this eerie silence? They have a few plausible arguments. The first is misidentification. A navigator's sunstone might not have been a beautifully cut and polished gem. It could have been a rough, unassuming chunk of raw crystal. An archaeologist digging up a grave might find such a stone and simply label it a gaming piece. A whetstone, a spindle whorl, or, most damningly of all, random rock. Without a clear context, it's just a stone. Another argument is that the sunstone was purely a functional tool, not a personal possession to be buried with its owner. A warrior was buried with his sword because it was a symbol of his identity. A navigator's sunstone, however, might have been seen as ship's property, a piece of vital equipment to be passed down from one seamaster to the next until it was lost at sea. Finally, there's the fragility argument. Icelandspar, the prime suspect, is a form of calcite, which is a very soft mineral. It cleaves easily and can be scratched with a copper coin. Over 1,000 years in the damp, acidic soil of northern Europe, it's possible that any buried crystals simply degraded, crushed by the weight of the earth or dissolving into nothing. But the skeptics have strong counterpoints. Vikings were often buried with other tools of their trade. Blacksmiths have been found with their hammers, and women with their weaving implements. If a great navigator were to be buried, why not with the single most important instrument of his craft? And while calcite is soft, we have found other, equally fragile materials like amber, jet, and even unburnt wood in well-preserved burials. The silence is stubborn. The central archaeological debate, therefore, is not whether the crystals could work, but whether the complete absence of physical evidence should outweigh the textual evidence of the sagas. It's a frustrating standoff between what the stories say and what the ground refuses to give up. As you sit on the deck, the initial euphoria of understanding the Sunstone gives way to this new, uncomfortable uncertainty. You look at Bjorn and his pouch. Is it possible that the sagas were just stories? That the physics is just a modern fantasy? What if the whole thing is a beautiful, elegant theory about a tool that never actually existed? The ship still has its course, but your neat explanation for it has just been thrown into doubt, leaving a deeper and more profound mystery in its place. The silence of the archaeological record is a powerful counter-argument. It hangs in the air, thick and uncomfortable, casting a deep shadow of doubt over the entire Sunstone theory. Your neat explanation feels hollowed out, on the verge of collapsing. The pouch on Bjorn's belt begins to seem like a prop in a story, nothing more. Is the whole idea just a romantic fantasy, a modern myth projected onto the past? The theory feels dead in the water. And then, nearly a millennium after your voyage, in the murky tidal currents off the Channel Islands, a team of divers finds something. Let's leave your chilly 9th century deck for a moment and fast forward to our time. Imagine the scene. Divers descending through the cold green water off the coast of Alderney. They are exploring the remains of a shipwreck, a scatter of cannons, anchors, and weathered timbers on the seabed. This is not a Viking longship. This is a much later vessel, an English warship from the Elizabethan era that went down in a storm around the year 1592. This is the age of Shakespeare, of Sir Francis Drake and the Spanish Armada. These sailors were the contemporaries of Galileo. They were part of a sophisticated maritime world that was rapidly mapping the globe. The wreck, discovered in the 1970s and still being studied today, is a treasure trove of late 16th century military life. But in 2002, amidst the lead shot and military equipment, researchers made a peculiar find. Lying in the sediment was a small, milky white crystal, cleaved into a distinctive rhomboid shape. And right beside it, they found a pair of brass navigational dividers. The proximity of the two objects was electric. It was the archaeological equivalent of finding a fossilized remote control, with a fossilized battery right next to it. The implication was immediate and undeniable. This crystal was somehow part of the ship's navigational toolkit. When the crystal was brought to the surface and analyzed, it was confirmed to be a piece of Iceland spar. While not perfectly transparent, it was of high enough quality to exhibit the classic double refraction property. It was the first time a calcite crystal, the prime suspect for the Viking Sunstone, had ever been found in a maritime context, directly associated with other navigational instruments. The archaeological silence had at last been broken. But this discovery raises a huge question. The ship sank around 1592, more than 500 years after the end of the Viking Age. And these Elizabethan sailors most certainly had magnetic compasses. So why on earth would they be carrying a sunstone? The answer is likely as loud and violent as the ship's main purpose, cannons. A 16th century warship was a floating artillery platform, packed with dozens of massive iron cannons. It has long been known that large masses of iron can deflect a magnetic compass needle, a phenomenon called magnetic deviation. Firing these cannons created a powerful temporary electromagnetic field that could send a compass spinning wildly. In the heat of a naval battle, a captain could find his primary navigational tool rendered completely useless by his own ship's weaponry. In that scenario, a reliable, non-magnetic backup for finding the sun's bearing would be invaluable. The Iceland spar crystal, immune to the magnetic chaos of battle, would have been the perfect tool. It wasn't their primary method of navigation, but it was a crucial failsafe. the 16th century equivalent of keeping a paper map in your glove compartment in case your phone's GPS dies. This single find proves that the principle of using a crystal to navigate was known and practiced in Europe long after the Viking Age. The discovery has sparked intense debate, with scholars arguing whether the Alderney crystal is the smoking gun that proves a long-standing tradition of crystal navigation, or simply an isolated anomaly, a historical curiosity with no connection to the earlier Viking practices. Is it the surviving heir to a secret passed down through generations of sailors from the Norsemen? Or was the technology forgotten and then independently rediscovered centuries later? We don't know. The wreck, known to researchers by the rather unromantic name 2 Elizabeth Thorfers, has given us our one and only solid piece of data, and in doing so, has opened up a dozen new questions. Back on your longship, this echo from the future changes everything. The absolute certainty of the silence is gone. You now know that at some point in history, a sailor found a use for this exact type of crystal on a ship at sea. The theory is no longer pure speculation. It has a single, tangible anchor in the real world. The plausibility of Bjorn's pouch containing a working navigational instrument has just skyrocketed. The silence hasn't been replaced by a clear voice, but by a tantalizing whisper, and that whisper is enough to keep the mystery alive and more compelling than ever. The Alderney crystal provides a crucial, tangible link. It proves the concept of crystal navigation isn't pure fantasy. But a 16th century English warship is a long way from a 9th century Viking nar. The theory, resurrected from the depths, still needs to prove it can actually swim. The only way to truly bridge the gap between the saga's cryptic clue and the archaeological silence is to stop speculating and start sailing. It's time to put the Sunstone to the test in the real world. This is the domain of a fascinating field called experimental archaeology. It's a branch of historical study dedicated to the principle of learning by doing. If you want to know how a Roman catapult worked, you build one and see how far it can throw a large rock, preferably in an empty field. If you want to understand ancient pottery techniques, you get your hands dirty with clay. And if you want to know if Vikings could navigate with a crystal, you build a replica longship, grab a chunk of Iceland spar, and sail into the foggy North Atlantic, hoping for the best. Its history as an extreme sport. In recent decades, a number of ambitious projects have done just this. Enthusiasts and scholars have constructed remarkable seaworthy replicas of Viking ships, like the Sea Stallion from Glendalough, or the magnificent Draken Harald Hårfagre, which in 2016 successfully sailed from Norway to North America. These voyages are invaluable, teaching us more about the practicalities of Viking seamanship than 1,000 books ever could. And alongside these epic journeys, more targeted scientific experiments have taken place. Researchers, the modern-day Bjorns, have armed themselves with a variety of potential sunstone crystals and have headed out to sea specifically to test their effectiveness. The good news? Under the right conditions, the sunstone works. It works astonishingly well. In numerous studies, both in computer simulations and on the decks of real ships, the Iceland spar dot balancing method has proven to be a viable navigational technique. On days with a light, uniform overcast, where the sun is hidden but the cloud layer is thin, researchers have been able to pinpoint the sun's direction with an accuracy of plus or minus just 1 degree. That is a stunningly precise reading, more than enough to establish a reliable course. These positive results suggest that the core physics is sound, and the proposed method is not just theoretical, but practical. The Sunstone is not a myth. It's a tool that demonstrably functions. However, the North Atlantic is rarely so accommodating. The bad news is that the Sunstone is a temperamental instrument, not an infallible one. When the weather gets really nasty, the crystal's performance starts to degrade. The biggest problem is thick, multi-layered cloud cover. When sunlight has to pass through multiple different layers of cloud, the polarized signal gets scattered and rescattered, effectively scrambling the information. The crystal might give a weak, ambiguous signal, or worse, a completely false one. The very conditions of deep fog or a raging blizzard, where you would need the sunstone most desperately, might be the exact conditions in which it fails. There are other limitations. The polarization pattern is weakest and most distorted when the sun is very close to the horizon. This means the sunstone is least reliable at sunrise and sunset, crucial times for a navigator to get a fix. And then, there's the ever-present challenge of the rolling ship. Modern experimenters, even with all their scientific knowledge, have reported the immense difficulty of holding the crystal steady enough to get a good reading on a moving deck. It requires an incredible amount of practice and an almost intuitive feel for the ship's rhythm. It's not a user-friendly device you can just pick up and master in an afternoon. Forget an instruction manual. This thing would need a 10-page waiver and a complimentary packet of motion sickness pills. The creativity of these modern experiments is remarkable. One of the leading researchers, a Hungarian biophysicist named Gábor Horváth, has taken his studies from the sea to the sky, using planetariums to perfectly replicate the specific lighting conditions of an overcast Arctic twilight. He's also a world expert on how animals like desert ants navigate using these same celestial polarization patterns, blending history, physics, and biology into a single grand investigation. The mixed results of all these real-world tests have shifted the goalposts of the Sunstone debate. The results of these experiments have led to a new debate, with researchers arguing whether the Sunstone was a primary, precision instrument used for daily navigation, or a coarse last resort tool used only to find a rough bearing during moments of total disorientation. Was it their everyday compass or their emergency flare gun? Back on your ship, this knowledge gives you a new appreciation for the man standing at the stern. Bjorn isn't just using a magical device that gives him a clear, easy answer. He is a master of a difficult, sensitive craft. His success depends not just on the stone, but on his own body, his years of experience, and his intimate knowledge of the sky's moods. He needs to know when the signal is trustworthy and when it's lying. The crystal doesn't give him the answer, it gives him a clue, one that he must interpret with a skill born of 1,000 days at sea. He is not a technician, he is an artist. The new image of Bjorn as a master craftsman, a virtuoso of his difficult instrument, is a compelling one. It feels right. But the more you consider the Sunstone as a real-world tool and not a legend, the more its flaws and limitations come into sharp focus. This was no magical GPS bestowed by the gods. It was a piece of technology, and like all technology, it had its bugs, its operational limits, and its moments of infuriating failure. To truly understand its role, you have to appreciate everything it couldn't do. First, there's the quality of the instrument itself. The modern experiments are usually conducted with high-grade, optically pure crystals. A 9th century Viking navigator would have been working with whatever he could find or trade for. His piece of Iceland spar was unlikely to be a flawless, transparent gem. More likely, it was a cloudy, semi-opaque chunk, riddled with internal fractures and mineral inclusions. Each one of those tiny imperfections would scatter and distort the light passing through, making the two dots in the dot balancing method blurry and indistinct. Finding that perfect point of equilibrium would be like trying to tune a piano that has a family of mice living inside it. The signal is there, but it's buried under a mountain of noise. This inherent imprecision leads to the next major issue, the 5-degree problem. While lab tests can achieve stunning accuracy, real-world experiments in North Atlantic conditions have shown that a more realistic margin of error for a sunstone reading is probably closer to plus or minus 5 degrees. 5 degrees doesn't sound like much. It's a tiny slice of the 360-degree circle, but on the vast featureless canvas of the open ocean, tiny errors have huge consequences. Imagine you're sailing the roughly 800 nautical miles from the coast of Norway to Iceland. If your course is off by a constant, uncorrected 5 degrees, you will miss your target by about 70 miles. You wouldn't just miss your intended fjord. You would miss the entire country, sailing past it into an even greater and more terrifying emptiness. A 5-degree error is the difference between landfall and being lost forever. It's also crucial to remember what kind of navigation the Vikings were practicing. They had no concept of longitude and only a rough, observational sense of latitude. Their primary method for long sea voyages was latitude sailing. A navigator knew, for example, that the settlement in southern Greenland was on the same latitude as Bergen in Norway. They could determine this by measuring the height of the sun at midday or the North Star at night, using their handspans or a notched stick against the horizon. Their strategy was to sail from Bergen, find that latitude, and then just turn west and keep the sun or star at that same height. A sunstone is a huge help in finding the sun on a cloudy day, but it can't measure its altitude. It helps you steer, but it doesn't tell you if you're drifting north or south of your intended highway. This highlights the sunstone's most fundamental limitation. It gives you a direction, but it does not give you a position. It is a compass, not a chart. If a storm blows you 100 miles south, the sunstone can help you point your ship west again, but it has no way of telling you that you're now on a completely different parallel track that will lead you to a different continent or to no continent at all. It provides a heading, but no context. It's a tool for moving forward, not for knowing where you are. And of course, there are the times it's completely useless. At night, it's just a rock. During the polar winter, when the sun barely rises, it's a mostly useless rock. And in a true whiteout blizzard or a fog so thick that it feels like you could carve it, the sky is a uniform wall of gray. No sunlight penetrates, which means no polarization. The sunstone would show nothing but two equally dim, blurry dots no matter how you turned it. In the absolute worst conditions, the navigator was just as blind as everyone else. Some have even floated the fringe idea that the complex interwoven patterns in Viking art were a kind of visual mnemonic, a way to memorize the shapes of coastlines or currents, because they knew their instruments could and would fail them. This host of limitations, the variable quality, the margin of error, the inability to measure position or altitude, has forced a major re-evaluation of the sunstone's role. This has led many historians to argue that the sunstone's primary value may not have been in setting a precise course, but in re-establishing a basic directional sense after a storm had passed or during a long period of overcast skies. It wasn't for the fine-tuning, it was for the big dumb. Where in the heavens is south? Question. It was a reset button, not a guidance system. This doesn't diminish Bjorn's accomplishment in your eyes. On the contrary, it enhances it. You now understand that the crystal in his pouch is not a single magical solution to the problem of the North Atlantic. It is one flawed, temperamental, but occasionally brilliant tool in a much larger kit. Its limitations mean he must have been relying on other things, other methods, other senses. You look away from the navigator and out at the sea itself, at the rolling waves and the distant cry of a gull. The answer isn't just in the stone. It's out here, all around you. You just have to learn how to read it. You now understand the sunstone not as a single solution, but as an imperfect tool that answers one specific question: where is the sun? But that knowledge alone is not enough. To navigate, you need to turn that single data point into a course, and to do that, you need context. You need to know the time of day. You need a way to measure and record that solar bearing. The crystal is only one half of a potential system. And so you begin to wonder, what was the other half? What else is in Bjorn's navigational kit? Perhaps the answer lies not in a crystal from the ground, but in a simple piece of wood, carved with strange and beautiful precision. Let's look at another tantalizing archaeological find. This one is not a post-Viking echo, but a genuine artifact from the heart of the Norse world. The year is 1948. An archaeologist is carefully excavating the ruins of a medieval convent in a fjord in Unartok, Greenland. And there, amidst the debris of a collapsed building, he finds a fragment of a small wooden disc. It's unassuming, about the size of the palm of your hand, with a hole drilled in the center and a series of intricate, triangular notches carved around its edge. For years, it was cataloged as a decorative object, maybe a lid for a small box, or a piece of a game. But some researchers saw something more in its precise geometric markings. They saw a potential sun compass. The theory behind how this Unartok disk might have worked is a beautiful piece of applied science. You would start by placing a small pin, or gnomon, into the hole in the center. To keep the device perfectly level, a necessity for accuracy, you might float it in a shallow bowl of water. On a clear, sunny day, the pin would cast a shadow. As the sun moved across the sky, the tip of that shadow would trace a curved path across the face of the disk. Now, here is where the carved notches become critical. Researchers believe these lines are not decoration, but data. They represent the path the shadow would trace on specific, important days of the year. the summer solstice, the winter solstice, and the equinoxes. By watching the path of the shadow and seeing how it lined up with these pre-carved mnemonic lines, a navigator could determine the time of day. More importantly, the shortest shadow of the day always occurs at local noon, when the sun is at its highest point in the sky, which marks true south in the northern hemisphere. By finding the point on the shadow's arc that was closest to the central pin, you could find a cardinal direction with very good accuracy. It is, in effect, a portable, reusable sundial and a compass all in one. But what happens on a day like today, when the sky is a blanket of gray and there are no shadows to be seen? On its own, the sun compass is just as useless as a sundial in a cave. This is where the two theoretical tools, the crystal and the wood, could have come together to form a system of almost modern elegance. The sunstone and the sun compass are the perfect partners, each one compensating for the other's greatest weakness. Imagine the workflow for Bjorn. The sky is overcast. He pulls out his sunstone and his wooden disc. First, he uses the crystal, balancing the dots, reading the color, whatever his method, to find the azimuth of the hidden sun. Now he knows the direction of the light source. Next, he takes his sun compass, with the pin in the middle, and holds it up. By aligning the pin with the sun's direction he just found, that faint, diffuse light from the clouds would cast that barely perceptible ghost shadow onto the disc. Now he has a shadow to work with. He marks its tip on the wood. By comparing that single mark to the carved lines on the disc, he can now do two things. He can confirm his directional reading from the sunstone, and more importantly, he can determine the time of day. He now knows not just the sun is there, but the sun is there, and it is 2 hours before noon. With direction and time, he can calculate his course with a level of precision that would be impossible with either tool on its own. One of the most intriguing details of the Unartok disk is a series of 32 notches carved into one of the main lines. 32 is a very specific number. It is the number of points on a classical compass rose: north, north by northeast, northeast, and so on. This could just be a coincidence of decorative carving, but it might also suggest that the Norse had a highly sophisticated system for dividing and describing directional space long before the magnetic compass rose became common in the rest of Europe. Of course, this is all a brilliant theory, but it remains just that. The function of the Unartok disk is still fiercely debated, with some archaeologists convinced it is a sun compass, while others suggest it could be a decorative button, a simple time-telling device for use in the monastery, or even a confession counter for tallying prayers. Without an instruction manual signed by Eric the Red himself, we may never know for sure, but the possibility is tantalizing. You picture Bjorn's toolkit anew. It's not just the leather pouch with the crystal. It's also a small, carved wooden disc, a pin, maybe a shallow soapstone bowl. It's a whole system. The navigator is no longer just an observer. He is a technician, an applied geometer, a man who uses one tool to power another. The combination of the Sunstone's light-finding ability with the sun compass's interpretive power feels like a complete and devastatingly clever solution to the problem of the northern seas. The image of the sunstone and the sun compass working in tandem is a powerful one. It feels like you've finally unlocked the secret, a two-part technological solution that is both elegant and robust. You picture Bjorn's toolkit, the crystal and the disc, a perfect marriage of physics and geometry. But then a new thought surfaces. What happens on a moonless, starless night in the middle of a storm, when the fog is so thick you can't see the bow of your own ship? In those moments, both the crystal and the disc are useless lumps of matter. The technology fails. What then? The horrifying answer is that if these gadgets were all the navigator had, you would be doomed. This is where you have to zoom out, to see the sunstone not as the key but as one small key on a very large ring. Viking navigation wasn't about a single magic bullet. It was a complex, layered system of interlocking techniques, a hierarchy of methods from the most precise to the most primal. It's like a modern airplane's navigation system. The pilot has a highly accurate GPS but also a radio beacon system, an inertial guidance system, a magnetic compass, and if all else fails, a physical map and the ability to look out the window. The genius is not in any one tool, but in the redundancy of the entire system. Bjorn's true genius lies in the depth of his personal list of backup plans. The primary tool, the one that underpinned everything else, wasn't made of crystal or wood. It was the navigator's own mind. Your people have no charts, no paper maps to unroll on a table. The map of the North Atlantic is stored in Bjorn's memory, encoded in sagas, poems, and rote-learned directions. You've heard snippets of them your whole life. A famous set of directions, later written down in a book called the Landnamabok, describes the route from Norway to Greenland. It is a masterpiece of oral navigation, a set of verbal waypoints. Sail west from the Hernar Islands in Norway, keeping Bergen to your south, until you are north of the Shetland Islands, which you should see only in very clear weather. Then sail west for a time, staying south of Iceland so that you only hear the birds and see the whales from its coast. And then you will find Greenland. These directions often measured distance in a unit called a dager sigling, which translates to a day's sailing. This wasn't a fixed measure like a mile or a kilometer. It was a flexible, experience-based unit, roughly 100 to 150 miles, that inherently accounted for the season, the type of ship, and the expected winds. To a modern mind, it sounds impossibly vague. But for a Viking navigator, it was a rich, data-laden instruction set, perfectly suited to the world he inhabited. Of course, these memorized directions are useless without the lifetime of experience needed to interpret them. Bjorn has likely sailed this route or parts of it many times before. His mind is a vast cross-referenced database of past voyages. He remembers the specific color of the water over a particular submerged ridge hundreds of miles from land. He recalls the way the wind smells when it blows off the glaciers of Iceland, even when the island is still a day's journey below the horizon. He is constantly, subconsciously, running a pattern recognition algorithm against the fire hose of sensory data the ocean provides. When his instruments fail, he falls back on this deeper, more intimate knowledge. This is his true toolkit, a set of skills that turn the natural world into a giant living map. He can read the ocean itself, interpreting the long, rolling swell patterns that travel for thousands of miles and hold their direction, even when the local wind shifts. He can read the sky, not just for the sun, but for the subtle clues in the clouds or the quality of the light. And he can read the wildlife, knowing that the flight path of a gannet can lead you to fish, and the flight path of a puffin can lead you to land. Historians and anthropologists continue to debate the relative importance of instrumental versus non-instrumental navigation, with some arguing the Sunstone was a critical innovation, while others maintain that deep environmental knowledge was always the true secret to their success. The truth is likely that both were essential. There are even tantalizing hints of other lost tools. One saga mentions something called a husasnotra, but gives no description of what it is or what it does. Fringe theories abound. Was it a simple tool for measuring the height of the North Star? A portable weather vane? We just don't know. It's a named object from their toolkit that is now a complete mystery, a reminder of how much we've lost. Your perception of Bjorn shifts for the final time. You had seen him first as a stoic keeper of secrets, then as a magician, a physicist, a technician, and a master craftsman. Now you see him as he truly is, a polymath of the sea. He is a biologist who understands the habits of birds, a meteorologist who reads the wind, a physicist who decodes the light, and a living library of his people's accumulated geographic knowledge. You realize you've been focusing on the tool when you should have been looking at the man. The secret to Viking navigation isn't in the pouch on his belt, it's behind his eyes. The true sunstone, the real compass, is the extraordinary human mind. Your new understanding of Bjorn as a master of a whole suite of skills changes how you see the world around you. You stop looking for a single simple answer in his pouch and start looking for the complex, interwoven answers in the environment itself. Your gaze drops from the impenetrable gray sky down to the churning slate-gray water that surrounds you. The ocean, which a moment ago was just a terrifying and chaotic force, the very definition of your problem, now becomes a potential source of information. You have to believe that to a man like Bjorn, this seascape is not a featureless wasteland. It is a text, and he knows how to read it. The first lesson in reading this text is to distinguish between the noise and the signal. The noise is all around you. The choppy, steep, angry-looking waves that are being kicked up by the local wind. They slap against the hull, sending plumes of icy spray into your face. Their direction is fickle, changing every time the wind shifts. To try and navigate by these wind waves would be like trying to find your way through a forest by following the direction a startled rabbit just ran. It's useless, temporary information. Bjorn pays them little mind. He is listening for a deeper, more ancient rhythm. He is listening for the swell. The swell is the ocean's memory. These are the long, rolling, almost majestic waves that are generated by powerful storms, often hundreds or even thousands of miles away. A hurricane off the coast of that yet-to-be-discovered continent, Vinland, could send a swell propagating across the entire Atlantic basin. Because these waves have an incredibly long wavelength, the distance between their crests can be hundreds of feet. They lose their energy very slowly and hold their direction with remarkable consistency, traveling in a straight line from their point of origin. They are the deep bass note of the ocean, a steady directional pulse that continues unabated, right underneath the chaotic treble of the local wind waves. To detect the swell, Bjorn doesn't just use his eyes. He uses his entire body. He uses the ship itself as a sensory organ. He stands at the stern, his feet planted, and feels the rhythm. He feels the difference between the quick, jarring shudder of a wind wave hitting the beam and the long, slow, powerful heave as the entire vessel rises and falls with the passing of a deep ocean swell. He can feel the period of the waves, the time it takes for two successive crests to pass. A short period means local chop. A long 10 or 15-second period. That's the signal he's looking for. By feeling the direction of this deep underlying push, he can hold a course long after the sun and stars have abandoned him. This is not a theoretical skill. It is a proven and still practiced form of non-instrumental navigation. The great Polynesian navigators who colonized the vast expanses of the Pacific were absolute masters of this art. They could detect swells and interpret their meaning with a subtlety that is almost beyond our modern comprehension. While we have no Viking training manual that explicitly says, Lesson 1. Feel the swell. The technique's proven effectiveness in other pre-instrumental seafaring cultures makes it almost certain that the Norse, masters of the North Atlantic, would have possessed a similar understanding. The true artistry comes in when the ocean decides to get complicated. Often, there isn't just one swell. There might be a primary powerful swell coming from a storm system in the west, and a secondary, weaker swell from a different system in the south. The sea surface becomes a complex interference pattern, a liquid checkerboard of peaks and troughs. The navigator must then untangle these signals to feel the primary rhythm through the confusion of the secondary one. It is a feat of concentration and sensory attunement that is difficult to even imagine, like listening to 3 different songs at once and being able to hum the bass line of just one of them. Oceanographers and maritime historians still debate how reliably a navigator could distinguish the primary swell from local chop during a chaotic storm when the sea surface becomes a maelstrom of conflicting waves. There must be a point where the noise simply overwhelms the signal entirely. Some have even suggested that a truly elite navigator might be able to detect rebound swells, faint reflected wave patterns that bounce off a distant coastline. By recognizing a familiar rebound pattern, he might know he was approaching a specific stretch of coast even when it was still 100 miles below the horizon. You close your eyes, trying to do what Bjorn does. You try to filter out the immediate slap and spray, the jarring shudders of the ship. You focus on the bigger movements, the slow, deep rhythm of the ocean's breath. At first, all you feel is a chaotic, nauseating jumble. But you wait, and you listen with your bones. And then for just a moment you think you feel it. A long, slow, majestic rise, a pause, and a long, slow, controlled fall. It is coming from a consistent direction. It is a pulse. And in that moment, the ocean transforms. It is no longer your enemy. It is a map. A vast, moving, liquid map that is offering up its secrets, if only you have the patience and the skill to read them. You are beginning to grasp the deep rhythmic language of the ocean swell. It is a language felt more than seen, a constant source of directional information whispering through the hull of the ship. But as you concentrate on this subtle internal sense, a sharp, piercing cry from above breaks your focus. You look up. A pair of gulls are wheeling and diving in the ship's wake, their white feathers a stark contrast to the gray sky. And you realize with a jolt that the navigator's attention is not confined to the water beneath him. His library of knowledge extends into the air itself. The birds are not just fellow travelers, they are living, breathing, feathered instruments. The key to this branch of natural navigation is a simple piece of ornithological knowledge. Not all seabirds are created equal. Some species, like the fulmar, are true wanderers of the open ocean. They can spend months or even years at sea, sleeping on the waves and feeding hundreds of miles from the nearest spit of land. Seeing a fulmar tells you only one thing: you are on the ocean. Thanks, Captain Obvious. But other birds are homebodies. Species like guillemots, puffins, and razorbills are coastal birds. They must return to their colonies on land to roost and breed. Their feeding range is biologically limited. A puffin, for instance, typically forages within 60 miles of its burrow. This simple biological fact creates a vast, invisible bird zone around any significant landmass. An island like Iceland doesn't just appear on the horizon. Its presence is announced long before, first by the distant swells reflecting off its coast, and then by the appearance of its avian inhabitants. When Bjorn spots his first puffin, he knows with a high degree of certainty that he has entered this zone. He may not know the exact direction to land, but he knows it is now within a day's sail. His search has been narrowed from the entire trackless ocean to a circle 100 miles wide. He has found the outer ring of the target. The real trick, however, isn't just spotting the bird, but interpreting its behavior. A bird that is circling lazily or diving into the water is simply feeding. It could be heading in any direction next. But a bird seen in the late afternoon flying low and fast in a straight, determined line is not looking for food. That bird is commuting. It has a full belly, and it is heading home for the night. Its flight path is a living arrow pointing directly to the nearest land. By taking a bearing on that bird's course, Bjorn can get a more accurate fix on the location of the unseen coast than any of his other methods might provide. The most legendary application of this technique comes from the pages of the Landnámabók and the story of Hrafna Floki, or Raven Floki, the man credited with being the first Norseman to deliberately sail to Iceland. The saga tells us that Floki didn't just rely on wild birds, he brought his own. He consecrated 3 ravens to the gods and took them with him. When he believed he was close to his destination, he released the first raven. It immediately flew up, got its bearings, and headed straight back the way they had come, towards the Faroe Islands. Floki knew he had not traveled far enough. He sailed on, and a few days later, released the second raven. This one flew into the air, circled for a while, and, seeing no land in any direction, returned to the ship. Floki sailed on. Finally, he released the third raven. This one flew high, then set off on a purposeful course to the northwest, and did not return. Floki followed the raven's path, and in doing so, made landfall on the coast of Iceland. This story illustrates a level of sophistication far beyond passive observation. It is the active use of birds as a biological technology, a feathered self-guided drone for finding land. It's an ingenious solution, though one imagines the logistics of keeping 3 large, grumpy ravens cooped up on a small, wet boat for weeks on end would have been challenging. This practice of using course-finding birds wasn't unique to the Vikings. Ancient sailors in the Indian Ocean were recorded using the same technique to find the coast of India. It seems to be a classic case of convergent evolution in the world of navigation. Naturally, the story of Raven Floki is a source of contention. Historians still debate how widespread the practice of carrying ravens actually was, with some seeing Floki's story as a literal account of a common technique, while others view it as a unique semi-legendary tale meant to give him his famous nickname and add a mythic quality to his voyage. You look up at the gulls again, seeing them now not just as birds but as potential signposts, as carriers of geographic information. The world feels richer, more interconnected. You scan the horizon, no longer just for a break in the clouds or a change in the waves, but for the tiny, dark shape of a bird flying with purpose. Bjorn's senses are attuned to all of it: the deep rhythm of the water, the invisible patterns of the light, and the purposeful flight of a creature returning home. The ship is a single node in a vast web of natural information, and your navigator is the master spider, feeling every vibration, interpreting every clue. You are becoming a student of the natural world, your senses sharpened by the endless sea. You scan the waves for swells and the sky for birds, piecing together a mental map from these fleeting environmental clues. Then, off the port bow, a great exhalation of breath erupts from the sea, a plume of mist hanging in the cold air for a moment before dissolving. It is followed by the immense, dark curve of a back sliding gracefully through the water. A whale. And you remember the old poets, who didn't call this expanse of water the ocean or the sea, but the Hronraid, the whale road. It's a beautiful, poetic name, but like so much from your culture, it is also deeply practical. Whales are not scattered randomly across the ocean. They are creatures of habit and necessity, following ancient migratory routes between their calving grounds in the south and their rich feeding grounds in the cold northern waters. A seasoned navigator like Bjorn would have an intimate knowledge of these routes. He would know that the spring migration of gray whales passes along a certain corridor. He would know where to find the feeding grounds of humpbacks that signal nutrient-rich waters, which are often found near land. Seeing a pod of whales and identifying their species and direction of travel was another crucial layer in his navigational system. It was a form of biological landmarking on an ocean that otherwise had none. If he was sailing from Iceland to Greenland in the right season and encountered the great whale migration, it was a powerful confirmation that he was on the right road. The whales were fellow commuters on this vast, invisible highway, their presence a reassuring sign that he was in the correct lane. It wasn't a precise tool for setting a course, but it was a vital check for confirming his general position on the vast canvas of the sea. For days, your world has been one of gray light and obscured views. But tonight, a miracle. The wind shifts, the thick blanket of cloud begins to shred, and patches of clear, dark sky open up above you. And in those patches, you see something you had almost forgotten existed. Stars, thousands of them, sharp and brilliant in the cold, clean air. A collective sigh of relief ripples through the crew. After being trapped in a small, gray room for so long, it feels like the ceiling has been ripped off the world. For Bjorn, this is a profound opportunity. He can finally consult the most reliable and unchanging map of all. His primary guide in this celestial realm is a single, unassuming star. It is not the brightest, but it is the most important. For it has a special magic, it does not move. This is the North Star, Polaris. Because it sits almost directly above the Earth's rotational axis, it is the still point around which the entire northern sky appears to turn. It is the linchpin of the heavens, a permanent, unwavering beacon marking true north. Bjorn would know how to find it by locating the familiar shape of the great constellation you call the Karlsvagn, the man's wagon, what later astronomers will call the Big Dipper. By following the line of the two outer stars in the wagon's bowl, he can pinpoint the location of this celestial anchor. Once he has the North Star, he can practice the most reliable form of latitude sailing. The height of Polaris above the horizon is a direct and unchanging measure of your ship's latitude. He can measure this angle using a simple notched stick, or even just his outstretched hand, a technique that, with practice, can be surprisingly accurate. If he knows his destination in Greenland lies at the same latitude as his home port in Norway, his job is simple. Sail west, keeping the North Star at the exact same height off the right side of the ship every night. If the star gets higher, he's drifted north. If it gets lower, he's drifted south. It is an incredibly robust and elegant system. Even the sun could be used at night during the high northern summer. At those latitudes, it often doesn't sink far below the horizon. The navigator could watch the sun set, and then hours later at midnight, see a distinct glow on the horizon where the sun was passing beneath his feet. That glow marked a perfect, unambiguous north. Astronomers and historians still debate how accurately a Viking navigator could measure the altitude of a star on the heaving deck of a ship, with some suggesting they achieved remarkable precision using simple handspan techniques, while others believe it was a much rougher, good enough estimation. And there are fringe theories that some of their carved wooden tools might have served as bearing dials, simple analog computers for tracking the movement of constellations through the night to tell time. You stand on the deck, the cold wind on your face, and watch Bjorn. He isn't holding a crystal or a disc. He's just standing there looking up, his face illuminated by the faint starlight. You watch his eyes trace the familiar path from the man's wagon to the still point of the north. In this moment, he is an astronomer. The uncertainty of the waves and the birds is gone, replaced by the cold, hard geometry of the cosmos. The ship, which has been tossed by chaotic, immediate forces for days, now feels connected to something eternal and unchanging. You are no longer just following a whale's path. You are aligned with the axis of the world itself. The stars above are a cold, clear map of cosmic certainty. The swell below is a rhythmic, liquid map of oceanic memory. The birds are a living, breathing map of biological necessity. You have now seen the individual pages of the Viking navigator's atlas, but the final, most crucial component is the one that binds all these pages together. You have been given the data streams, but you are still missing the most important part, the processor. You look at Bjorn, standing quiet and still under the stars, and you understand that the true marvel of this whole system is not in any one tool, but in the astonishing mind that can synthesize all this information. His brain is a massively parallel supercomputer, constantly running a dozen different programs at once. One part is feeling the ship's pitch and roll, filtering the swell from the chop. Another part is listening, identifying the distant cry of a gannet colony. Another is scanning the constellations, calculating latitude from the height of a star. Yet another is accessing a vast internal database, comparing the current watercolor to the memory of the watercolor at this point on his last voyage. Smell, temperature, the taste of the salt in the air, all of it is being fed into this central processor, weighed, analyzed, and cross-referenced. This level of mental acuity is a product of an oral culture. In a world with few or no written texts, memory is not an incidental skill. It is a core technology. It is a muscle, exercised daily to a degree that is almost incomprehensible to a modern, literate mind. The great skalds, the court poets of the Viking Age, were the living embodiment of this power. They could compose and recite, from memory, epic poems of staggering length and complexity, governed by strict rules of alliteration, meter, and metaphorical language. A single poem could be a history lesson, a political treatise, and a work of art. The same mental architecture required to master this poetic craft would be applied to the art of navigation. Bjorn does not need to consult a chart because he has become the chart. His mind holds a three-dimensional, multi-sensory map of the entire North Atlantic. We call it intuition, that mysterious gut feeling a seasoned expert has. But intuition is not magic. It is the result of the subconscious brain processing thousands of data points and recognizing a subtle pattern long before the conscious mind can articulate it. Bjorn might suddenly order a small change of course, and if you asked him why, he might just grunt and say, "It felt right." But what actually happened was that his brain registered a 1/10 of a degree drop in water temperature, correlated it with a slight shift in the swell period, and the sighting of a particular type of whale, and concluded without conscious thought that the ship had just entered the cold East Greenland current requiring a slight correction to the west. Modern science gives us a fascinating glimpse into this kind of extreme mental mapping. Licensed taxi drivers in London must pass an incredibly difficult test called the knowledge, which requires them to memorize the layout of 25,000 streets and 100,000 points of interest. Brain scans of these drivers have shown that the process of acquiring the knowledge physically enlarges the posterior hippocampus, the region of the brain vital for spatial memory. A Viking navigator like Bjorn would have possessed a knowledge of the sea that was orders of magnitude more complex. A map not of static streets but of moving currents, shifting winds, and seasonal migrations. His brain was likely, in a real physical sense, the brain of a different kind of human. Cognitive scientists and archaeologists still debate whether this profound environmental attunement was a skill that anyone could learn, or if it was a rare talent possessed by a select few individuals who were neurologically predisposed to this kind of pattern recognition. Was every ship captain a Bjorn? Or were men like him rare and highly sought-after specialists, the superstars of the sailing world? You realize now that you've been on the wrong quest. You wanted to understand the secret of the Sunstone, But the Sunstone is just one word in a long and complex sentence. The real secret is the language itself. It is a language written in the subtle grammar of the waves, the vocabulary of the birds, and the eternal syntax of the stars. Bjorn is not just a speaker of this language, he is its greatest living poet. Even if he handed you his crystal, his wooden disc, and his entire mental atlas of memorized directions, you would still be hopelessly lost. You lack the one indispensable instrument, the lifetime of experience that has calibrated his senses and his mind to the deep, silent, and powerful rhythms of the world. You now possess the theoretical knowledge. You understand the sunstone, the compass, the swells, the birds, and the stars. You appreciate the immense cognitive power of the navigator, who must synthesize it all. Now let's put this entire system to the test. Let's place it in the hands of a real man on a real voyage, one of the most consequential in your people's history. Your ship is no longer just a vessel of the imagination. It is part of a small fleet, and your navigator is no longer the anonymous Bjorn. He is a man with a fiery red beard and a fearsome reputation. He is Eric the Red. And this is not a trading run. This is a voyage into complete emptiness driven by desperation and a rumor of land to the west. The year is 982 AD. Eric is an outlaw. He has been banished from his native Norway for manslaughter. He settled in Iceland, but his violent temper led to more feuds, and now he has been exiled from there too, for 3 years. He has literally run out of world. His back is to the wall. His only option is to sail west, chasing a story of a land seen briefly by a sailor named Gunnbjörn, who was blown off course decades earlier. This is not a voyage of discovery for glory's sake. It is a desperate bid for survival. You stand on the deck of Eric's ship as it pushes off from the Snæfellsnes Peninsula in western Iceland. Your final landmark is the magnificent ice-capped volcano of Snæfellsjökull, a perfect cone that will remain visible as a land scene, a final land site, for over 100 miles of your journey west. This is a classic latitude voyage. Eric knows he needs to sail due west, and for the first few days the weather is clear. At night he keeps the North Star at a constant height off the starboard beam. During the day he uses a wooden sun compass tracking the shadow of the central gnomon to maintain his course with precision. Then, on the third day, the sky clouds over. The sun compass is useless. This is the first test. Eric is unconcerned. He pulls out his sunstone. With the familiar, practiced motions you've imagined, he finds the sun's position behind the clouds, confirms his westward heading, and the ship sails on. He constantly feels the rhythm of the ship, his feet telling him that the deep, driving swell is still coming from the east, a reassuring push from the world he has left behind. By day 6, the weather worsens. A thick, wet fog descends and the wind whips the sea into a chaotic frenzy. The Havila closes in. Now the sunstone is useless. The fog is too thick. The swell is confused by the storm waves. All instruments, physical and environmental, have failed. This is where the navigator's mind becomes the only tool that matters. Eric relies on his internal clock, his dead reckoning. He knows his ship's average speed. He knows how long they have been sailing in this storm. He holds the course by sheer force of will and an almost supernatural feel for the sea, keeping the ship pointed into the void. On the 8th day, the fog thins, and then you see it. A small black and white bird, a guillemot, flies past, heading southwest. It is a coastal bird. Land is near. Eric tastes the sea spray on his lips and feels it's less salty, a sign of fresh water from glacial melt. He sniffs the air and catches a faint, earthy, almost mossy smell under the scent of the salt. Then, ahead, you see a strange pale glow on the horizon, a luminous band of light at the base of the clouds. It is the Jökull skin, the glacier shine, the eerie reflected light from a massive ice sheet still below the horizon. They have not just found a coast, they have found a coast of ice. Now the true challenge begins, navigating the treacherous field of sea ice that the East Greenland current pushes down the coastline. This requires a completely different skill set, one of nerve, patience, and expert ship handling. Eric spends his 3 years of exile exploring this new land. He finds deep fjords, protected from the worst of the winds, where the summer sun allows for lush, green pastures. When his exile is over, he sails back to Iceland, a phenomenal navigational feat in itself. to gather settlers, and here, he reveals his genius not just for navigation but for marketing. He calls this land of ice and rock Greenland because, as the sagas dryly note, men would be more readily persuaded to go there if it had a good name. It's one of the most successful branding campaigns in history. The 10th century equivalent of an apartment complex called Paradise Gardens that's located next to a sewage treatment plant. Archaeologists and climatologists still debate how much greener Greenland actually was during the medieval warm period, with some arguing Eric's name was a bald-faced lie, while others contend that the southern fjords would have been genuinely lush and fertile summer pastures, a startling contrast to the icy interior. You make landfall with Eric and his first wave of colonists. You sail into a deep fjord, and you see what he saw. The land is harsh, dominated by the immense blue-white wall of the inland ice cap, but here, at the sea's edge, are meadows of green grass and wildflowers. It is a stark, beautiful, and empty world. Eric the Red, an outlaw with nowhere else to go, has crossed a deadly stretch of ocean and found a new home for his people. He did it by being a master of the complete Viking system: the sun, the stars, the stones, the swells, the birds, and above all, the vast and powerful map he carried in his own mind. You are a Greenlander now. You've helped build a settlement in a new, harsh but beautiful land, a foothold on the very edge of the known world. Life is a cycle of summer pastures and long, dark winters, huddled around the fire, listening to the old stories and creating new ones. But the Norse spirit is one of restless curiosity. You look west from the highest peaks of the settlement, out over the Davis Strait, and you see nothing but open water. To the west of the world's edge, what is there? The map in your mind, once filled, now has a vast, terrifyingly blank page. The answer comes not from a planned expedition, but from an accident. A trader named Bjarni Herjolfsson sails from Iceland, intending to join his father in Eric's new settlement. But a ferocious storm blows in from the north, trapping him in a dense fog for many days. He is deep in the Hafila, completely lost. When the weather finally clears, he gets a sun fix and sails on. But the land he eventually sights is not the glacier-clad coast of Greenland he was expecting. It is a low, forested coastline. He knows he is lost. In a move that would frustrate future generations of historians, Bjarni, a practical man of commerce with little interest in glory, decides not to land. He's late for dinner, basically. He turns his ship northeast and sails for several more days, sighting two more distinct and unknown landmasses before he finally finds the familiar coast of Greenland and makes his way to the settlement. Bjarni's story becomes a local curiosity, a tale of the lands he saw but didn't bother to visit. But the story catches the ear of a young man with ambition in his blood. Leif, son of Eric the Red. Leif is captivated by the idea of these unknown lands. He seeks out Bjarni, questions him on every detail, and then, in a move that shows his incredible confidence, he buys the very ship that made the accidental voyage. He gathers a crew of 35 men, and you are one of them. Your mission: to sail west and deliberately find the lands that Bjarni stumbled upon by mistake. You set sail from Greenland, but your course is not due west. You are heading southwest into a truly unknown quadrant of the ocean. This is not a simple latitude voyage. This is an exploration into the blank part of the map, a challenge that will require every tool and every ounce of skill your navigator possesses. After some days at sea, you make your first landfall. It is a barren place of flat rocks and great glaciers in the interior. There is no green here. Leif, in a moment of literal-minded naming, calls it Helluland, the land of flat stones. This is likely the Baffin Island of modern maps. You do not stay. You push south along the coast and find a new land, this one low-lying and covered in forests. Leif names this Markland, the forest land. This is a vital discovery for you Greenlanders, who have no local source of timber for building. But this is still not the land of Bjarni's description. You sail on for 2 more days with a northeast wind at your backs, and then you find it. A land that is temperate, rich, and welcoming. You have arrived in a place Leif will eventually name Vinland, and here we move from saga to solid ground. In the 1960s, archaeologists excavating a site at the northernmost tip of Newfoundland in Canada, a place called L'Anse-aux-Meadows, uncovered the remains of a small Norse settlement. They found the outlines of turf-walled longhouses, a forge for working iron, and artifacts of unmistakably Norse origin. It is the only confirmed Viking site in North America. The concrete, scientific proof that these voyages, described in the sagas, actually happened. The saga account of your arrival in Vinland sounds like a paradise. The rivers are teeming with the largest salmon you've ever seen. The winters are so mild that your cattle can graze outside. And most famously, one of your crew discovers wild grapes growing, which prompts Leif to name the land Vinland, the wine land. This abundance of wild grapes, however, presents a puzzle, as they do not grow as far north as Newfoundland. The exact location of Vineland is perhaps the most contentious debate in Norse studies, with scholars pointing to the wild grape discrepancy to argue that the L'Anse-aux-Meadows settlement was just a gateway or base camp, and the true warmer Vinland described in the sagas lay further south, perhaps in New Brunswick or even New England. In a classic case of historical storytelling being messy, the two main sagas that describe these events, the saga of the Greenlanders and the saga of Eric the Red, give slightly different and contradictory accounts, a reminder that they are histories filtered through the lens of oral tradition. But for you, standing on this new shore, the academic debates are centuries in the future. You are here. You have sailed from Greenland across a dangerous and unknown sea to a new continent. It is arguably the single greatest navigational achievement of the age, the culmination of centuries of accumulated knowledge. It was done without a magnetic compass, without a sextant, without a single written chart. It was done with a wooden ship, a deep understanding of the natural world, and the quiet, unwavering genius of a navigator who could read the cosmos in a crystal and the map of the world in his own mind. You are standing on the shores of a new world, a testament to the supreme mastery of the Norse navigational arts. This great arc of exploration, from the coasts of Norway to the shores of Vinland, seems impossible without a secret weapon, a technological edge. The Sunstone, a beautiful theory of physics and history, feels like the perfect answer. And yet, as you pull back from the story and look at it with the cold eye of a modern scholar, you find that the entire magnificent edifice is built on a foundation of fierce and unresolved debate. The case for the Sunstone is far from closed. Welcome to the enduring scholarly standoff. It is a fascinating three-way deadlock between what was written, what was possible, and what has been found. On one side of the ring, you have Team Saga. These are the historians and literary scholars who argue that you cannot simply ignore the primary texts. The sólarsteinn is mentioned. It is treated as a real object. While the sagas are not scientific manuals, they are the product of a culture's memory, and the casual, unexplained nature of the references suggests the object was familiar enough not to need an explanation. To dismiss it entirely, they argue, is an act of chronological snobbery, assuming that because we don't understand it, it couldn't have been real. In the second corner, you have Team Science. These are the physicists, the experimental archaeologists, and the modern-day adventurers. Their argument is simple and powerful. The theory works. They have taken the crystals, gone to sea, and proven that under many conditions you can find the sun's location with remarkable accuracy. They point to the Alderney shipwreck as proof that the general technology of crystal navigation was a real, historical practice. For them, the successful modern experiments and the sound physics are compelling evidence that the Vikings, masters of the sea, could and would have discovered and utilized such a powerful and obvious natural phenomenon. They are the mythbusters of the Viking Age, and their verdict is a firm plausible. And in the third corner, weighing in with the heavy, undeniable force of negative evidence, is Team Silence. These are the field archaeologists, the ones who have spent their lives in the dirt, carefully excavating the Viking world. Their argument is the most difficult to refute. If this tool was so important, so widely used, and so critical to their expansion, we should have found at least one by now. The complete and utter lack of a single confirmed sunstone from a Viking Age context is, for them, the trump card. All the clever theories and tantalizing stories in the world cannot change the fact that the ground itself has offered up nothing. An argument from silence is not absolute proof. But as the decades of digging continue, that silence grows ever louder. This entire modern debate, it is worth noting, was largely kicked off by one man. Before the Danish archaeologist Thorkild Ramskou published his scientific theory in 1967, the Sunstone was little more than a literary footnote, dismissed as folklore. It was Ramskou who connected the legend to the physics of polarization, transforming a piece of medieval literature into a testable scientific hypothesis and igniting the controversy that still burns today. So where does that leave us? The most likely truth, as is often the case, may lie in a synthesis of these positions. Perhaps the Sunstone was not a common tool issued to every sea captain. Perhaps it was a rare and valuable piece of specialist equipment, a secret of the trade known only to a few elite navigators who undertook the most ambitious voyages. This elite specialist theory elegantly resolves the standoff. It would explain why the stone was remarkable enough to be mentioned in the sagas, while also explaining why it was so rare that we have yet to find one in the archaeological record. It wasn't the Timex watch of the Viking world, it was the limited edition handmade tourbillon. The scholarly standoff remains a fascinating deadlock between compelling textual clues, plausible scientific theory, and a profoundly empty archaeological record, leaving the true role of the Sunstone in the Viking Age uncertain. The topic has even escaped the quiet halls of academia and now rages on internet forums and message boards, a kind of open-source historical investigation where enthusiasts passionately debate the evidence and share the results of their own homemade experiments. And in the end, you are back on the ship. The academic arguments fade into an abstract hum. You see the pouch on your navigator's belt. Is there a sunstone inside? Maybe, maybe not. And you realize that the uncertainty is what makes the story so powerful. By stripping away the reliance on a single magic gadget, it forces you to confront the true scale of their genius. The deep knowledge of the sea, the sky, the wildlife, and the incredible power of the human mind to make sense of it all. The mystery in the end is perhaps more satisfying than the solution. The scholars can have their standoff. The quiet, unresolved mystery of the Sunstone is, in its own way, deeply satisfying. But the modern world of storytelling is not a fan of ambiguity. Where historians see a complex debate, filmmakers, game designers, and novelists see a fantastic opportunity. They see a magical gem, a lost piece of ancient technology, a perfect plot device. While the academics carefully weigh the evidence, popular culture has grabbed the Sunstone with both hands and sprinted off with it, transforming the navigator's subtle instrument into a legendary artifact. In the world of fiction, the Sunstone often becomes what is known as a MacGuffin, an object that drives the plot and motivates the characters, a tangible representation of a quest. And there is no more prominent example of this than in the popular television series Vikings. Here, the Sunstone is introduced early on as the secret weapon of the protagonist, Ragnar Lothbrok. It is his key to sailing west, his proof that he is smarter and more visionary than the conservative chieftains who are content to raid to the east. The show depicts it as a clear crystal, and its use is simplified for the screen. Ragnar holds it up to the overcast sky, and by looking through it, he finds a bright spot that marks the sun's position. It becomes a symbol of his destiny, a physical manifestation of his ambition. This depiction has single-handedly cemented the Sunstone in the minds of millions as a core piece of Viking technology. From there, it has bled into other forms of media, especially video games. In sprawling historical fantasies like Assassin's Creed Valhalla, the Sunstone is the perfect kind of collectible. It's a treasure item, a piece of lore, a shiny object that fits neatly into an inventory slot. It gets distilled from a complex tool requiring immense skill into a simple power-up, the kind of thing that might give your character a +5 bonus to navigation, if such a skill existed. It is an easy and evocative way to add a touch of historical flavor and mysticism to the game world. In this way, the pop culture Sunstone is a bit like the most famous piece of Viking fiction, the horned helmet. It is a powerful, instantly recognizable symbol, but it's a romanticized exaggeration. The historical fact is that there is zero archaeological evidence that Vikings ever wore horned helmets into battle. That iconic image was an invention of 19th century artists and opera costume designers who wanted to make the Norsemen look more dramatic and fearsome. The simplified, magically infallible Sunstone of the screen is the horned helmet of Viking navigation, a compelling fiction loosely inspired by a more complex truth. So why has this particular artifact, above all the other aspects of their navigation, captured the modern imagination so fiercely? Part of it is our fascination with lost ancient technology. We love the idea of older civilizations possessing knowledge that was forgotten, like a historical version of a sci-fi story. The Sunstone fits this narrative perfectly. It also straddles the enticing line between science and magic. It works because of real, verifiable physics, but its effect, seeing the invisible, feels like a superpower. It allows a historical story to have a touch of the fantastical without breaking the rules of reality. Cultural historians often debate whether these popular portrayals help or hinder public understanding, with some arguing they spark a genuine interest that leads people to discover the real history, while others lament the way they oversimplify a complex navigational system into a single magical gadget. The legend has even spawned a cottage industry. You can go online right now and buy your own Viking Sunstone, usually a piece of Iceland spar in a rustic leather pouch, sold to enthusiasts, history buffs, and modern pagans. It has become a tangible piece of the new Norse mythology. The dramatic images from the screen fade from your mind. You are back on the ship, in the cold, wet, unforgiving reality. You look at the idea of the real Sunstone, not a glowing gem, but a cloudy, imperfect piece of calcite. A difficult, temperamental tool that only works under certain conditions and requires a lifetime of experience to read correctly. The fictional version is a simple, powerful story. But the truth, the story of a navigator who reads the waves, the birds, the stars, and his own fallible instruments with a skill born of deep, holistic knowledge, is a far more complex and, ultimately, a far more impressive tale. The pop culture image of the glowing, magical Sunstone fades, leaving you with the more complex and impressive reality of the navigator's holistic skill. And in that quiet space, a new idea takes root. The Sunstone, whether it was a common tool or a rare artifact, has become something more than just an object of historical debate. It has become a powerful metaphor. It represents one of the most fundamental and beautiful aspects of human ingenuity, our endless quest to see the invisible. The world you perceive with your unaided senses is a radically simplified version of reality. A comforting, low-resolution summary, edited for your convenience. Your eyes can only see a tiny, almost insignificant sliver of the electromagnetic spectrum, a narrow band we call visible light. The vast universes of radio waves, microwaves, infrared, ultraviolet, X-rays, and gamma rays are completely invisible to you. They are passing through your body right now, carrying information from distant galaxies and radio stations, but you are blind to them. The Sunstone is a symbol of every instrument we have ever built that allows us to peek into these other realms. A thermal camera is a kind of sunstone, translating the invisible world of heat into a visible image. A radio telescope is a sunstone the size of a valley, showing us the shape of the cosmos written in a language of light our eyes will never see. This quest to reveal hidden worlds is not new. In the 17th century, a Dutch draper named Antony van Leeuwenhoek, with no formal scientific training, became obsessed with grinding tiny, perfect glass lenses, far more powerful than any that had existed before. He was not looking for anything in particular. He was just curious. One day he put a drop of pond water under his lens, and in that moment, he became the first human being in history to witness the teeming, invisible universe of microorganisms. An entire kingdom of life had existed on Earth for billions of years, completely unknown, until one man invented the right stone to see it. His simple microscope did for biology what the Sunstone may have done for navigation. It made the invisible visible, and in doing so, changed our understanding of reality forever. The Sunstone is a perfect symbol for this process because it doesn't show you something new. It reveals a hidden pattern in something you've been looking at your whole life. The polarized light is always there, imprinted on the sky every single day. You just lack the sensory equipment to perceive it. This reminds us of the concept of Umwelt, the unique sensory world that every living creature inhabits. The Umwelt of a bee is a world of ultraviolet patterns on flowers and the celestial map of polarized light. The umvelt of a dog is a rich tapestry of smells. The sunstone, in a way, is a passport. It allows you for a moment to step outside your own limited human umvelt and borrow the superpower of a honeybee. Philosophers of science still debate whether we truly discover these patterns as pre-existing realities, or if we, in fact, invent them by imposing our own cognitive frameworks upon the chaos of the universe. Is the constellation truly in the stars, or is the pattern of the Great Bear a story we have projected onto a random scatter of lights to make it meaningful? The sunstone sits right on this beautiful blurry line. The polarization is real, a physical property of light. But the meaning, the fact that it can be used to find a direction and guide you home, is a human invention, an act of pure genius. The legend of the Sunstone, then, is also a story about recovering lost knowledge. It challenges our comfortable, linear idea of progress. It reminds us that our ancestors may have possessed ways of seeing and understanding the world that we have forgotten, skills that have been amputated by our reliance on easier, more universal technologies. The work of the experimental archaeologist trying to relearn how to read a crystal or a swell pattern is an act of remembering not just for history, but for humanity. Your journey is almost over. You stand on the deck of this imagined ship, but you are no longer the same person who boarded it. You look at the gray sky and you see the ghost of a great geometric bow tie of light. You look at the churning sea and you feel the faint rhythmic pulse of a distant storm. The world has not changed, but your perception of it has been fundamentally altered. The sunstone, real or not, has done its work on you. It has become your own personal tool for seeing the hidden patterns, a reminder that the world is always deeper, stranger, and more wonderfully complex than it appears if you just know how to look. The journey through the past, through the science and the sagas, is drawing to a close. You have stood on the shores of Vinland, you have debated with scholars, and you have seen the world through the lens of a pop culture camera. Now, for one last time, you are back on the deck of the longship. The endless uniform gray of the day is finally beginning to yield. The sun, a pale disk you haven't seen for what feels like an eternity, is sinking towards the western horizon. It is the hour of twilight, and the watch is now yours. You are the navigator. You stand at the stern, your feet planted on the familiar deck, feeling the life of the ship as if it were an extension of your own body. You are the calm center of this small floating universe, the single mind responsible for the 30 souls aboard. You begin your final check, a quiet, personal ritual, a synthesis of all the knowledge you now possess. Your eyes go first to the sun. You watch the last brilliant sliver of it dip below the waves, marking its precise location on the horizon with a mental notch. The sky above it is on fire, a riot of orange and purple that will linger for hours. In that light, you see the dark, purposeful shapes of gannets, flying low and fast, their day's work done, heading home. You note their direction. Then you close your eyes and listen with your body. Underneath the chatter of the wind-whipped waves, you feel it, deep and steady. The long, ancient swell, your constant companion. A rhythmic push from the east that tells you of the vast ocean at your back. You turn your face to the wind, feeling its cold bite on your cheeks, tasting the salt. But there is something else in it now. A new scent, faint and subtle. A trace of damp earth and crushed leaves under the brine. It is the smell of land. The first stars begin to prick the deepening violet of the sky directly overhead. You find the Karlsvon and trace the familiar line to the still point of Polaris, confirming your latitude. Your gaze sweeps the twilight arch, that band of polarized light that remains in the sky long after the sun has gone. You don't need the sunstone anymore, not really. But you reach into your pouch anyway. You hold up the cool, smooth crystal, a cloudy piece of calcite, and you look through it at the glowing sky. You turn it, and you see the colors shift and the brightness balance, confirming what your senses have already told you. The patterns are all there, all in agreement. The system is working in perfect harmony. You are living in the twilight of an era. Soon the great voyages of discovery will end. The settlements in Vinland will be abandoned. The ultimate fate of the Greenland colony, which vanished sometime in the 15th century, is a profound historical mystery, with scholars debating whether it was due to climate change, conflict, or gradual assimilation. a final, silent end to this great westward journey. But for now, in this moment, you are at the apex of its achievement. Every voyage across the open ocean is a journey into the Ginnunga Gap, the formless void of myth. And your job, as navigator, is to draw a line through that void, to create a world of order and purpose with nothing but your senses and your wits. And then you see it. Your eyes, now perfectly attuned to the low light, pick it out. A subtle break in the perfect curved line of the horizon, a place where the darkness of the sea meets a deeper, more solid darkness. It is not a cloud, it is land. You feel no great surge of triumph, no desire to shout the news. There is only a quiet, deep, and profound sense of completion. You have done your work. You have read the secret languages of the world and they have led you home. You stay there for a long time, watching the dark line grow, a new world emerging from the twilight. The wind is soft now. The rhythm of the waves is a gentle lullaby, and the great journey is finally over. And so, our own journey together comes to its gentle conclusion, leaving the shores of the past to find our own quiet harbor in the present. The story of the Sunstone, with its beautiful blend of science and saga, is a reminder that the world is so often more intricate and filled with more hidden wonders than we can possibly perceive at a glance. It teaches us to look closer, to listen more carefully, and to appreciate the almost magical power of a human mind that has been carefully calibrated to the subtle rhythms of the natural world. The ship has reached its destination, the crew is safe, and the navigator can finally rest, his mental maps dissolving into the peaceful, featureless landscape of his dreams. The sounds of the ocean are beginning to fade now, replaced by the soft hum of the fan in your room and the quiet settling of your own home. Let the darkness behind your eyes be as calm as a windless fjord, and allow the gentle rise and fall of your own breathing to be the only swell that carries you now, rocking you slowly and peacefully into a deep and untroubled sleep. There are no more courses to plot, no more storms to endure. There is only this moment of quiet stillness, a safe and welcome landfall at the end of a long day.